Hi, this is a supplementary math lesson for Algebra 2. And so this is going to we're going to re-go over lesson 43 on sine, cosine, and tangent functions. Okay, so and in fact, for the rest of the year in Algebra 2, we're going to focus on trigonometry. Okay, that has specifically to deal with properties, geometric properties of right triangles. Okay, a triangle in which one of the angles is 90 degrees, right triangles. Remember, trigonometry, trigonomic functions only apply to right triangles. Okay, so with that, we're going to get into analyzing vectors, and that's going to finish out our year. So pretty much from here on out, we're not going to be doing review problems of previous sections. We're just going to do the problems applicable to that section of the day. You'll notice your homework sets are very minimal, anywhere from 3 to 6, maybe 7 problems. Okay, so you need to focus on showing the work, doing them properly, because if you just simply don't do it, that's a lot off. And we only have to. You need to show the work, check your answer. Maybe you're putting a lot of eggs in one basket there. Okay, so that's something we're going to kind of accelerate here over the next 2 weeks in Algebra 2. We're going to focus on our trigonomic functions, vectors, expressing vectors in polar form, in rectangular form, splitting apart vectors, combining vectors, adding them. Okay, so that's basically what we're going to do. And the building blocks for all of that is your trigonomic functions. Okay, and so they have 3 areas in this homework set that they'll ask you possibilities to do. They'll give you a right triangle, and they'll just say, okay, give what the sine of a particular angle here, angle A, given some information on that triangle. So you need to know your definitions of your trigonomic functions. Okay, the sine of an angle. Our angle of interest is angle A here. What is the side? It's simply a ratio. It's an expression of side length over side length. Well, what side length? The sine of an angle is a ratio of the side opposite to that angle, in this case 4, over the hypotenuse, 7. Okay, we don't typically express, if they want a sine, what is the sine of an angle, we'll express that as a decimal. Okay, when we divide that out, it becomes 0.57. Okay, the cosine of that angle is a ratio of the side length adjacent to the angle. The side length adjacent to this angle is this one here. Okay, 5.47 over the hypotenuse. The hypotenuse is 7. Okay, when we divide that out, what do we get? Well, let's see. They don't have that one done in the book. Let me do it on my calculator here quick. 5.74 divided by 7 equals 0.82. Okay, and the tangent. Okay, the tangent, again, a ratio of what side length? The tangent is the opposite side length over the adjacent side length. Okay, we don't usually leave that as a ratio. We'll divide it out. Comes to 0.87. Okay, so that's one possibility. Another possibility is they'll give you some information on a triangle, and they'll say, give us the side lengths, and we're going to use our trig functions to do that. Okay, let's solve for the hypotenuse here. Okay, what trigonomic function has the hypotenuse in it? Okay, our hypotenuse here was 7. We had 2 trig functions with 7, the sine and the cosine. You can use either one, it doesn't matter. The cosine angle is 35 degrees is going to equal the ratio of the adjacent side length, that's my A, over the what? The hypotenuse. Oop, the hypotenuse is H, okay? I guess I can't use the cosine because I have two unknowns, all right? Let's use the sine then. The sine of that angle, 35 degrees, equals the ratio of what? The opposite side length, 5, over the hypotenuse, H. Ah, much better. I only have one unknown now, okay? Problem is, H is in the denominator. Need to send it over there, so I'm going to multiply by an H here to get rid of it, and multiply it here to get it over to this side. Then I'm going to divide by a sine 35 on this side. I must do so on this side, okay? I'm basically rearranging my equation like so, okay? Another way to think of it is cross-multiplying, okay? If I cross-multiply, I get a H sine 35 equals 5, then I must divide out that sine of 35, okay? So I hope that didn't confuse you there as far as doing that. So what I did here is I multiplied by H to get rid of it. I brought the H over here. Then I divided out this sine function, and the sine then I divide out over here, and it becomes 5 divided by the sine of 35. So that's what I put in my calculator. 5 divided by, hit my sine button, type in 35, close off my parentheses, I hit equals. Okay? H will equal 8.72. Okay? I can do the same thing to find A, okay? Now, this is a rounded off number. I'm not going to use that one again. I'll use the exact numbers they give me, okay? In this case, okay, I would use the tangent function. The tangent of 35 degrees is equal to what? It's the opposite side length over the adjacent side length. It's the same equational setup there, okay? So A will equal 5 divided by the tangent of 35 degrees. Let me do that real quick. 5 divided by tangent button, 35, close it off, equals 7.14. Oops, 7.14. Okay, so H equals 8.72, A equals 7.14. Okay, now you should always double check your trig answers in this way. Okay, we know the hypotenuse always has to be the longest side length in a right triangle. So that's one check. Is it that the case here? Yes, it is. Okay, and we know the smallest side length is the side opposite the smallest angle. Okay, well, is it the smallest angle? Well, this is 35 and this is 90. Okay, so this must be 90 minus 35. Okay, this is a 55 degree angle here. They all add up to 180. Okay, so this actually is our smallest angle. The side opposite to it should be the side with the smallest length, 5. It is. Okay, and then the side with the medium angle, the angle in medium, in between 90 and the smallest, should be the side length in the middle of the 3. And we see that it is there. So that's one way you can check your answers with trigonometry. Make sure that they come out. Okay, does it fit the geometry of the triangle? So you can use those simple checks. Okay, is the hypotenuse the longest? Is my shortest leg length opposite my smallest angle? Is my medium angle opposite of my medium leg length? Okay, that will help you check your answer. Okay, and then the third way, they'll have you solve a problem with triangles is they'll give you information on a triangle, then they'll want the angle measurement, okay? In this case, we have all three side lengths available to us, so we have all three trigonomic functions available to us. Let's use the cosine, okay? So the cosine of this angle C is going to equal what? A ratio of the adjacent leg length. What is the adjacent to C? Here is C. Here is the leg length adjacent to C. It is 8 divided by what? The cosine is the adjacent divided by the hypotenuse, 10. Okay, so now I have that ratio, the cosine of C. Okay, what is C? It's an angle measurement. And so what do we say to solve for an angle measurement? We want C equals to, what do? We take the inverse cosine expressed as cosine to the -1 to stand for inverse. That's how it will be generally expressed on your calculator as well, okay? 8 over 10, okay? So how do I do that? Well, I go on mine, the inverse cosine function, I have to hit the second function button and then hit the cosine button. That will give me the inverse cosine, and then it gives me a parentheses, and I just type in that ratio, 8 divided by 10. I close the parentheses and hit equals. Okay, what does that give me? C equals 36.87. What is that? That's not a measurement of length, it's a measurement of angle. It's in degrees. Okay, so that is my answer. I use my inverse functions to determine the angle. Okay, I'll use my normal trig functions to determine leg lengths. Okay, so I hope that review helps. You have a short homework set for tonight. Shoot an email or a text message with any questions. So long for now. Bye.